Okay, so we're going to spend another day on writing parallel and perpendicular equations because it is vastly important. So let's review. First things first, parallel equations have the same slopes. Perpendicular equations have opposite reciprocals. So always keep that in mind whenever we are trying to find parallel and perpendicular lines. Okay? So if I look at number 1, they want us to pass through point 2, 3 and be parallel to y equals x minus 4. Well, first things first is we have to make sure this is in slope-intercept form, which it is, and then identify the slope. The slope is whatever's next to x, and here the slope is 1. Since the slope is 1 and we want parallel, that means we're going to keep it 1. So we're going to use our point in our slope in our point-slope formula. So y, the opposite of positive 3 is to subtract 3, equals the slope 1, parentheses x, the opposite of positive 2 is to subtract 2. Then I solve for y, so I distribute first. 1 times x is 1x, 1 times negative 2 is negative 2. I'm going to add 3 to both sides, so y equals x, negative 2 plus 3 is plus 1. And here's my new equation. I know that they're parallel because they have the same slope, and if I were to graph this, it would go through the point 2, 3, okay? Number 2, they also want to make it parallel, but this time it's in standard form. I cannot identify the slope if it's in standard form, so we need to convert it to slope-intercept. So first thing I'm going to do is to subtract 2x. So I have 3y equals negative 2x plus 3. I'm going to divide everything by 3. So y equals negative 2 over 3 is negative 2 over 3x. And positive 3 over 3 is plus 1. The only reason we converted was so that we could identify the slope. And the slope is negative 2/3. Now, we are going to keep it the same slope because we are looking for parallel. So now we're going to use our point in our slope. Y, the opposite of negative 1 is to add 1. And parentheses equals the new slope, or the slope, parentheses x, the opposite of negative 6 is to add 6. Then I'm going to distribute and solve. So negative 2/3 x, negative 2/3 times positive 6, and this is where you might use your calculator, is negative 4. Then I'm going to subtract 1, so y equals negative 2/3 x, negative 4 minus 1 is minus 5. How I know they're parallels because they have the same slope, and if I were to graph this, it would go through the point negative 6, negative 1. Now that's parallel, meaning same slope. Well, perpendicular means opposite reciprocal slopes. So always make sure it's in slope-intercept form, which this is, and we're going to pull the slope out, which the slope of this equation is 2. But the perpendicular slope to 2 is opposite reciprocal. The opposite of positive is negative, and the reciprocal of 2 over 1 is 1/2. So we are actually going to use a new slope of negative 1/2 with this point. So y, the opposite of positive 8, is to subtract 8. The new slope is negative 1/2, parentheses x. The opposite of negative 2 is to add 2. Then I'm going to distribute and solve. So y minus 8 equals negative 1/2 x. Negative 1/2 times positive 2 is negative 1. Then I'm going to add 8 to both sides. So y equals negative 1/2 x. Negative 1 plus 8 is plus 7. I know that they're perpendicular because they're opposite reciprocal slopes, and if I were to graph it, it would go through the point negative 2, 8. Number 4, also perpendicular, but we cannot identify the slope without converting this to slope-intercept form. So we're first going to subtract x. 4y equals negative x plus 8. I'm going to divide everything by 4. So y equals negative 1/4 x. Positive 8 over 4 is plus 2. Again, the only reason I did this was to pull the slope out. The slope of this equation is negative 1/4, but we want the perpendicular, so that means opposite reciprocal. The opposite of negative is positive, and the reciprocal of 1/4 is 4 over 1, which is just 4. So we are going to use 4 and then the point to find the new equation. So y, the opposite of negative 11, is plus 11, equals my new slope, which is 4. parentheses x, the opposite of negative 2 is to add 2. Then we're going to distribute and solve. So 4 times x is 4x, 4 times 2 is 8. I'm going to subtract 11. So y equals 4x, 8 minus 11 is negative 3, or minus 3. And this is my new equation because I know that they are perpendicular because they have opposite reciprocal slopes. If I were to graph this, it would go through the point negative 2, negative 11. Okay, just 2 more practice problems on the front here. They want us to write the equation of a perpendicular line to the line 5x minus 3y equals 12 and passes through the point 3, 1. So remember, perpendicular means opposite reciprocal. We first need to convert standard form to slope-intercept form. So we're going to subtract 5x, negative 3y equals negative 5x plus 12. I'm going to divide everything by negative 3. So y equals negative 5x over negative 3 is positive 5 over 3x. And positive 12 over negative 3 is minus 4. Again, the only reason we converted was so we can identify the slope. And the slope of the original equation is 5 over 3. Perpendicular means opposite reciprocals, so we need to find that. The opposite of positive is negative, and the reciprocal of 5/3 is 3/5. Now we're going to use our new slope and a point to find my new equation. So y, the opposite of positive 1 is to subtract 1, equals my slope, negative 3/5, parentheses x. The opposite of positive x is to subtract, or positive 3 is to subtract 3. Then I'm going to distribute and solve. So negative, that is right. Yeah, negative 3/5 x. Now, usually it doesn't come out this way. I messed something up. Perpendicular, 5x divided by negative 3. Okay. Now we're going to multiply. So negative 3/5 times negative 3 is positive 9/5. We're going to add 1 to both sides. So y equals negative 3/5 x. 9/5 plus 1 is positive 14/5. So not the prettiest equation. For whatever reason, it's not perfect on the y-intercept, but this is my new equation. They are opposite reciprocals. Number 6, they want us to find parallel, so that means same slope, but I cannot identify the slope without converting first. So we're going to subtract 3x. So I have 2y equals negative 3x plus 8. Divide everything by 2. So y equals negative 3 over 2x. 8 over 2 is positive 4. The only reason we converted was so we can identify the slope, and we are going to keep this slope the same because we want parallel. So y, the opposite of 0 is 0, so you can just put y equals. The slope is negative 3 over 2, parentheses x. Opposite of positive 4 is to subtract 4. So y equals negative 3 over 2x. Negative 3 over 2 times negative 4 is positive 6. And this is my new equation, and it is parallel because they have the same slope. Okay, so we're going to talk about special cases. So this is what's going to be new on your assignment today. So if I look at number 7, it says we want to find a line that passes through the point negative 2, 1 and is parallel to the x-axis. Okay, notice it didn't give me an equation for this one. All they gave me is they want it parallel to the x-axis. Okay, now for me, I like to draw a picture. So I'm going to draw a little mock example of a coordinate plane. And what I'm going to do is I'm going to plot negative 2, 1, roughly. Of course, this is not perfect, but negative 2, 1 is like going left 2, up 1. So I know it's around there, okay? And all I know is it goes through this point, and we want it to be parallel to the x-axis. Well, if it's parallel to the x-axis, it's a horizontal line going through that point right there, okay? So we have to find the equation of this line. Well, which axis did it cross? It crosses the y-axis. And where does it cross the y-axis? Well, that's where I look at my coordinate right here. Which one is the y? The negative 2 or the 1? The 1 is the y, so it crosses at y equals 1. Okay, let me do it again in case I lost you. Let's see. So let's do number 9. I'm going to skip down. A line that passes through the point 3, -4 and is parallel to the y-axis, okay? So if I were to make a little graph and I plotted 3, -4, that's right 3 down 4, that's around right there roughly, and I know it's parallel to the y-axis. The y-axis is vertical, that means it's going to be parallel. It's going to be a line going vertical as well. Well, what is the equation of this line? Since it's vertical, it's going through the x-axis, so it's x equals, and where does it go through the x-axis? Well, if I look at my coordinate, which one is the x? The 3 or the -4? Well, I know that x is the 3, so x equals 3. It crosses the x-axis at 3 there, okay? If I look at number 8, a line that passes through the point -2, 1, but is perpendicular to the x-axis. Again, I'm just going to draw a picture. -2, 1 is left 2 up 1. But this time, they want perpendicular to the x-axis. Well, if it's perpendicular to the x-axis, that means the opposite direction. So it's not going parallel, it's going perpendicular, which means it's a vertical line that's going through the x-axis, so it's x equals. And where is it going through the x-axis? Well, if I look at my coordinate here, it's going through -2. Number 10, they want us to pass through the point 3, -4, but is perpendicular to the y-axis this time. So if I graph 3, -4, it's roughly right there. They don't want parallel to the y-axis, they want perpendicular. So it's not going to be parallel, it's going to be perpendicular, which means it's going to actually be horizontal. And it goes through the y-axis. And where does it go through the y-axis? Well, that's where I look at my coordinate, and it goes through -4.